All right, so in this video, we're going to talk about linear functions. So linear has the word line in the actual word. So we're talking about functions that are in a line, in a straight line. So one of the topics that comes up is something called the equation of two variables. And so the two variables that the equation will have is an x and a y. So when we talk about a linear equation, this is going to be a non-vertical line. This is important because a non-vertical line is not a function, okay? And we want linear functions. And the vertical line fails the vertical line test, which is why it's not included. So any other line would be okay. And we want to use the form y equals mx plus b. And what makes a linear function linear is that it has a constant rate of change. And in math, we call that the slope. And in this formula, the m is slope. And m is slope because of two words, mountain and climbing in French. Both have the word, starts with the letter M. I don't recall the exact words. And they were by a guy named Rene Descartes. And that's why m is used for slope. So although it seems kind of odd, that's the history of slope and why m is used, okay? So this is important. If it's linear, it has a constant rate of change, and that is slope. Okay, so on a graph, right, here's an example of a linear function. It's simply just a straight line, and there's many other versions that and variations you can have. We just cannot have a straight line vertically. That's not a function. Now, a nonlinear function has no constant rate of change. And so a function like this might look something like that, or it might look something like this. Okay, and you can see that these have curves. And because they have curves, they're not linear. Okay, and so the rate of change is actually not constant. Now, in a table, if you're given a table, how do you know if those values are linear or not? Well, what you want to do is compare the change between the coordinates. So what is the change in this table from 0 to 1? We're adding 1. What about from 1 to 2? We're adding another 1, okay? But now the slope is a ratio, right? So keep in mind that m is the ratio of y over x, the change of y over the change of x. So in this example, our change of x is 1. Okay, let's see what our change of y is in this case. This would be plus 4, and this would be plus 4. So our slope in this case is 4 over 1, 4 over 1. And since each of those changes are the same, this is a linear function. Okay, now if we look down here, we notice that the x values change by 1. And then we notice that we change by 2, and then change by 4. So this is not a function because one change is 2 over 1, and one change is 4 over 1. And so because the changes are not constant, are not the same, this is not a function. Okay. All right, now if we're identifying functions that are linear, or equations that are linear, here's a couple hints for you guys. We want the form y equals mx plus b. That's really the only form we want. So we don't want anything with an exponent. So if you ever see anything with something like that in there or any other exponent value, that's not a function. That's not a linear function. That's a different type of function. If you see something like this with a square root or a cube root or anything like that, that's probably not a function as well. If you see something where x is on the bottom and some numbers on top, this is not a linear function either. Okay? So those are a couple examples of non-linear functions by identifying them. We want something, what is a linear function would be something like 3x plus 2. That would be linear. So what we're looking for is that we have this m and the x term, and the x only has a power of 1. That's what we're looking for, okay? All right, now in the last video in functions, we talked about discrete and continuous. Well, we could also have a discrete linear function and a continuous linear function. So this would be an example of a continuous linear function. Okay, so for continuous, it would be something like this. Okay, where it's a straight line and all the points are included in the function. Now a discrete one might be something from a table. We have table values. And so we might have 0, 4, and then, you know, something of that sort where we're plotting points and that's it. We don't have values in between that are given to us. So in these cases, these are both linear, but this is discrete and this is continuous.